So we are back. Today should be Wednesday, the 18th. I will not be there. So you'll have a sub for today. Because I have to do some training in a district office. So I won't be there. So because of that, we are going to do something easier. Because I don't really want to just do a video on the elimination method while I'm not there. I think you'll have a lot of questions about that. So we are going to do something that it should be easy enough. I skip ahead on one of the chapter. Instead of doing 7.3, I'm going to do 7.4 first. It's called the consistent and inconsistent system. So basically, we are trying to define if like a system of equation is consistent or not consistent. So there's the definition. This definition over here is actually from your book, and it says the definition of a consistent system. A system of equation is consistent if it has one or infinitely many solutions. So one or infinitely many sounds, complicated, and it's actually really not too bad. I'm going to show you what it means very soon. So consistent system is based on these two things, whether you either have one or as many solutions as possible. So it's about when we talk about solutions, remember that it's those intersections, okay? That means we have one intersection. This is as many as possible. And of course, if we are talking about inconsistent, obviously it's the opposite of that. A system of equation is inconsistent if it has no solution. So we are going to figure out what it means by whether something is consistent or inconsistent very, very soon. And let me at least tell you what's going to happen in this lesson. You're going to finish this video. I don't think it's going to be that long, and then you have, just like the last marking period, you'll find a little quiz related to this. It's going to be very simple. It's just the basic stuff to determine if something is consistent, inconsistent, and later on I'll also talk about another set of things you can determine. And then after that, after you finish the little quiz, hopefully you'll do fine with that. Then possibly, I think I'm going to print out the exercise from your book, and you guys are just going to do that for either classwork or homework. So for today's lesson, it should be very simple. Finish watching this, do the little quiz, make sure you do the quiz though, and then you carry on with your homework or classwork. This one should be very straightforward, hopefully. Okay, let's dive in. So for example, I have a system over here. Obviously this time we are not solving it just yet. Well, we are going to solve it, of course, but basically we want to see if it's consistent or not consistent. Oops. Oh. Versus inconsistent. So basically we're saying that whether we have one solution or two solutions or not. Okay. There's easy way, there's difficult way. Let's talk about the easy way first. So if I'm going to draw this again, this is equation 1. This is equation 2. If I'm going to draw this, I want to see what's going on, and I will explain what it means by that. Let's just go there and draw it. This thing is trying to kick me out. There you go. So the equation actually sets y minus 4, not minus 4, equal to 4 minus x. Y is equal to 3x minus 6. So I draw these two lines. I can see that the intercept were over here. Let's zoom in. So the solution to this system is going to be 2.5 and 1.5. So if we go back to the definition about consistent system, it says you are going to get one or infinitely many So 1 or infinitely many, that means if you draw it, there's one solution. In this scenario, we have 2.5 and 1.5. That means, oh yeah, we actually have a solution. So this one is actually a consistent system. So this is a consistent system. Easy. Oops. Easy. Because we can just draw it out, it come out with one point of intersection is consistent. However, sometimes they like to ask you to check this out like another way. So they may say use substitution or use like algebra to solve it. That means you're not going to graph it. So hopefully you remember from last class, if it's in this scenario, y is equal to 4 minus x, y is equal to 3x minus 6. That means y and y are the same, right? Because it's exactly the same thing like we did substitution. We are trying to find y is equal to something, y is equal to something. So we can pair this up together. So I'm going to pair up the 1 and 2. So this y is going to be equal to, I'll just say I'm going to sub y is equal to 3x minus 6 in 1. Okay, so because I'm just simply using the second one, so this turns into 3x minus 6. That is going to be 4 minus x. So we're going to maneuver this a little bit. This is a little bit more tricky, but hopefully you can follow. So I want to move all the x to the left hand side, so this negative x, be careful about that. This is the whole thing. I'm going to add an x, and I'm going to add the x over there. That will cancel out 3x plus x. That turns into 4x. Copy that minus 6. Copy that equal sign. Copy that 4. Then the rest of this is just like moving that 6 to the other side, that negative 6. Plus 6 plus 6, so 4x is equal to 10, and then divide by 4, x is equal to 2.5. Alright, oops. So I actually have a value for x. So just like before, x is equal to 2.5. And I don't have my y just yet. It doesn't matter which one I pick because both of them will give me the same y. So I'm just going to use the first equation. So y is equal to 4 minus 2.5. I can do that in my head. It's going to be 1.5. Wow. Alright, so 2.5, 1.5 is the solution. That actually is the same as whatever I got over here. Alright, if they didn't say if you have to use substitution or algebraic method, you can always just draw it out. It's much easier to see it graphically whether it's consistent or not. If you have one solution, it's very easy, really. So that's that. So algebraic, you go ahead, calculate it. If you actually have the x and y, you actually have a solution coming out of this, then yeah, it's going to be consistent. So let's try another one. 4x minus 2y is equal to 4, y is equal to 2x plus 1. I'll draw it out again and see what's going on. Okay, 4x minus 2y, I think, is equal to 4. Y is equal to 2x plus 1. What's going on outside? Okay. As you can see, you can zoom out. You can zoom out quite far away, and you will notice that the green and the orange line, they will never run into each other. If they will never run into each other, they will never intersect. If they never intersect, then that means there's no solution, right? If you remember that, the solution to an equation basically means where they meet each other. So in this scenario, because they are basically parallel, if they're parallel, then there's no solution. There are many ways to check this. So you can draw it, and I'm going to show you how to do it by substitution. This is an inconsistent. This is inconsistent. Okay, this is an inconsistent system because they will never run into each other. So I want to show you how to do it algebraically. This is not too bad. Again, first one, second one. Second one, I know that y is already equal to 2x plus 1. That means these two are the same. So I can substitute that in there. So sub the second equation in 1. Second equation is y is equal to 2x plus 1. So 4x minus 2, I'm copying the first equation and change everything in there to 2x plus 1, which is equal to 4. Then, just like the previous example, not previous, like on Monday, you have to distribute this. You're gonna get 4x minus 4x minus 2. All of this is just distributing it correctly. Is equal to 4. Now, this is quite interesting if you think about it. 4x minus 4x, that will turn into 0, right? This thing actually disappear. So you're left with a statement. Negative 2 is equal to 4. So you have to think about it. Negative 2 is equal to 4. Of course it's not. If you have negative 2, the other side has to be negative 2. So this statement that you're looking at, negative 2 is equal to 4, is a false statement. It doesn't make sense. It makes no sense. So they will never run into each other. So if you ended up with a statement like this, that makes no sense, that means there's no solution. Okay, so if you're solving it algebraically, and you ended up with a statement that just doesn't make sense, your variable disappears somewhere, you just have two numbers comparing, and they're not the same thing, then you have no solution. So in this scenario, they have no solution. It agreed with our finding from drawing it out. Drawing this out basically said they're parallel. And over here, after you solve it, this makes no sense. That means it's no solution. Okay. Another way to do it is just to check if they're parallel or not. So if we're going to check it if it's parallel or not, we can check their slope. Remember that the slope over here is going to be 2. Y is equal to mx plus b. So m is equal to 2. So for the second equation, the slope is equal to 2. I can fuss with this for a little bit. I want to turn that into the mx plus b form. So I want to keep the y, so I'm going to move that 4x to the other side. I ended up with negative 4x plus 4 divided by negative 2 everywhere. So y is equal to 2x minus 2. So again, the slope is equal to 2. Now that is for students to actually remember, all of these, or how all these things actually tie to everything. So another way, that's another way. The things in red is another way. That is, just check the slope. If the slopes are the same, that means they're parallel, so they'll have no solution. So there are many different ways to check these kind of things. Obviously, most of you will opt for just graphing it. It's much easier to see if that is the case. Right. Now, then how about the very last one? That's another condition we still haven't covered. Right? We know that when there's 1, that is when the graph actually cross each other, there's 1 point for intersection. Now we know what it means by no solution. That line is just going to be parallel. I hope I can just write this out. So when two lines are parallel, basically it means it's no solutions. One solution, that's when they cross each other. How about this one? This one is a little bit confusing, but I can show you. So for example, I have a system like this. Let's just make it simple. X plus y is equal to 4, and then the other one possibly is like 2x plus 2y is equal to 8. Alright, so let me show you this magic. I'm gonna go back to decimals. I'm gonna draw it. I said x plus y is equal to 4. Okay, so it's this one in, let's make it a brighter color. This one in orange, okay? So the other one I said is 2x plus 2y equals, so pay attention to it when I'm going to fill this up, is equal to 8. Okay? See that? This black line, can they not mow their lawn like a 10 on Saturday morning? Don't they have better things to do? Like math? So you can see that the black line is basically the same line as your orange line. So I can click this away. So the orange line is x plus y is equal to 4. And then you have this 2x plus 2y is equal to 8. So for infinitely many solutions, that's the last scenario. That is, the two lines actually overlap. When they overlap, basically these two are the same line at the end of the day. Yeah, the number may be a little bit different, but it will come out the same. Okay, so let's see what we can do. So if we are actually solving it, drawing it is easy. If we are actually solving it, what will happen? This is the first equation, this is the second equation. This time, my x and y, they are not just, sitting there, so I have to do something. So for example, I'm going to keep the x. I'm going to move this y to the other side. So my first equation turns into this. X is equal to 4 minus x, 4 minus y. So I'm going to sub this, I'm going to substitute this. In the second one. Okay? Hopefully we have covered this, because when I make the video earlier I didn't talk about this, but I'm pretty sure in class I'll show you an example that we actually have to maneuver this before substitution. So in this scenario, my x over here turns into this 4 minus y, so 2 times 4 minus y plus 2y is equal to 8. Because I'm substituting the second one, so I'm copying everything, just change this x to whatever x I have. So, distributing this, you'll get 8 minus 2y plus 2y is equal to 8. Pay attention to this. Negative 2y plus 2y, or 2 minus 2, that disappear. So you're left with a statement that says x is equal to 8. Now, compared to the previous example with the no solution, x is equal to x, that makes sense. This is completely valid. 1 is equal to 1, 0 is equal to 0, 5 is equal to 5. So this is actually a true statement. So in this scenario, if you're actually solving it algebraically, you come out with two numbers and they're equal to each other, then is how many solutions? Oh, as many as possible. So this is infinitely many. So for consistent and inconsistent system, basically this means it's the same line. So this is basically same line. Okay, so there are only 3 ways to talk about something that's consistent, there's something that's inconsistent. So if there's only one solution, if they cross each other, it's a consistent system with one solution. If they are the same line, it's consistent and has many solutions. Finally, you may have something that are parallel, then that's an inconsistent system with no solution. Okay? So, I know the video is a little bit long, but it's okay because I'm not going to be there. Oh, I don't know why. I should have done this elsewhere. Dependent and independent. So this is actually quite simple. Independent and dependent system only applies to consistent thing. So we are talking about one solution or infinitely many solutions. So it only applies to consistent system. Okay. Otherwise, we can't talk about independent versus dependent or not. So it has to be consistent system. So somewhere along the line, you may have to check something and see whether it's consistent or inconsistent. And then after that, we can talk about what is independent and what is dependent. So this is really, really not too bad. It's going to last the next 2 minutes. An independent system has only one solution. So examples would be anything that if you draw it, it looks like a cross. You know, you have the intersection point in the middle, then that will be a consistent independent system. Okay, so then it's not too bad. Most of the system of equation, you have one solution, then it's a independent system. Alternatively, hopefully you can see how it goes. Because for consistent system, there are only two ways to go. You either have one solution or infinitely many solutions, right? So for infinitely many solution, that's going to be I can't spell. So this basically means a diagram, they are the same line. That's basically the key, same line. So for the one that are parallel, we don't really care about them because they are not giving us any solution. They are not giving us any point to look at. Remember back in the Monday or no, last week, when we were talking about the DVD versus cable TV, we want to find a solution because I cannot determine which one is going to be cheaper until I find the solution. And I look at the month after that. After 10 months, I look at the 11th month, which one actually cost me more, then in the long run, that's going to cost me more. So infinitely many solution basically means both of them, they cost the same price. So it doesn't matter if you choose like DVD versus cable TV. And if they're parallel, they'll never run into each other. So you're comparing two things. For example, you are buying DVD players versus buying magazines. They are two different things. You can't compare them. It's comparing apple and orange. So they'll always be parallel. There's no point of intersection. It has no meaning. So that's why in this chapter we are always concerning about the solution. And so just to wrap this up, consistent system basically means if you draw it out, there's going to be one solution or the same line, infinitely many. If it's not the case, it's inconsistent. And under the consistent system, you have the independent versus dependent. So it has one solution versus many solutions. The last bit, like this page, the independent, dependent, I do think it's important that you'll be able to tell the difference. So, having said that, this video is a little bit long because I'm not going to be there today. Otherwise, I'll break this into little parts. So if you have to rewatch this a couple of times or just certain parts are not okay with it when you're doing the test, just come back to it. The little quiz is going to be quite simple. I'll ask you, or maybe I'll give you a diagram and say whether it's consistent versus inconsistent, or I'll give you a pair of equations. You can draw it on decimals and find that out. So basically like true or false questions. So have fun with this. After the test, just work on the classwork. If you couldn't finish it in class, Happy does homework. Bye for now.